kickoff streams. My name is Jess, and today we have another exciting project for you to dive into. Earlier today, we saw the Zaros contest part 2 going live, and in this stream, we're going to sit down with the developers and get guided through this code base. As always, if you have any questions about this repo, please post them in the live chat and we will come to them at the end of today's stream. If you are watching this at a later time, then head over to the Cyfrin Discord, which is linked in the description. And we have a channel specifically for this contest where you can ask each other questions and ask the Zaros team some questions as well. Now, before we get started, I would like to quickly highlight that this contest has an end slot of 3006, and we have a prize pool of $70,000. So that's $23 per line of code. And this contest is running until Thursday, the 6th of February. Now, let's get started. Before we introduce Pedro to the stage, let's quickly run through what this code base is. So Zaros is a Perpetuals Dex powered by boosted restaking vaults. It seeks to maximize LP's yield generation while offering a top-notch trading experience on Arbitrum and Monad in the future. Now, many of you may have taken part in the Zaros Part 1 contest, so you may have been waiting eagerly for Zaros Part 2, and it is finally here for you to take a proper look at. Now, let's introduce Pedro to the stage here. Pedro is the developer over at Zaros, and he is going to give us a walkthrough of the code base today. First of all, Pedro, if you could just introduce yourself and Part 2, the scope of Part 2 and what this involves on a higher level.
Sure. Thanks for having me today, Jess. It's a pleasure to finally present you guys with Part 2. We've been building this for a while now, working hard. So yeah, I'm quite excited to see, especially those who participated in Part 1, taking part of Part 2 now. And well, about myself, I'm the CTO of Zaros, one of the engineers building the protocol. So yeah, it's been quite fun. I will share my screen now and quickly show a little bit about the README and how you guys can set up the project in your machines, and then go over the most key components of Part 2.
Yeah, that sounds absolutely amazing.
And Jess, please feel free to interrupt me anytime. I get excited and start speaking a lot. So let me know if there are any questions or anything. Okay.
Yeah, take the stage.
So, all right, thank you very much. About Zaros, as she mentioned, it's a perpetual Dex powered by these boosted restaking and staking vaults. We call them restaking or staking vaults because we mainly deal with yield-bearing assets, but it can really be any type of ERC20 token initially on Arbitrum that we want to integrate with. We have a list of different collateral types that we are going to support. And if you want to have a look at some base protocol configuration, it's all inside the script directory, and we have different entities like margin collaterals, markets, the actual market credit configurations in the market making engine, the perp market configurations. So all of this, in some sequencer and Oracle stuff is also here. So all of this type of config that may be useful to understand what parameters we deal with. So it may be helpful to find to assess where potential risk areas can be. It's a good start as well. We've created our sort of own proxy pattern that has already been audited in Part 1. Mainly sort of taking inspiration from diamonds and using also EAP 721 for upgradable libs, but that's not really main thing for this contest here. And also I'll quickly go over building the project. We are using actually Cyfrin's template now for this version. I don't remember if we were in the previous one, but you can just run make install and make build to compile the project. I'll run it now. Hopefully it works live. Yeah. By the way, guys, I really recommend you as soon as you install the project to build it, even if you're just gonna read the code, do it as soon as possible because the project is huge. In total, we have I think almost 8K lines of code, like not normalized, but like actual lines of code without normalization. And then if you take into account like scripts and tests, everything, it's about like 33K of Solidity lines. So it's huge. And it often takes like 15 to 25 minutes to compile. So it's really good. Like if you just build the project first before you do your modifications. Otherwise, when you want to add something, it will take forever. And you might even ask, oh, it's not working. It works, it just takes a long time. Okay, so yeah, I guess it's gonna, I'm not sure if it's gonna compile in time for the live stream here. But going over the main structures of the repo. So as I mentioned, why did I mention tree proxy pattern before? Because it's key for understanding like where like the actual entry points to the project are. Here in part 2, we were working with the market making engine. So the market making engine is the actual root proxy of the market making protocol of Zaros. And all of the branches, which you can visualize as modules, are inherited by it in the interface level, and we link them through also our scripts here. If you go over the tree proxy pattern utilities. And mainly, all of these branches present a different set of functionalities that you should expect to see when going over the code. So for example, I will open, I think, the most like sort of like complex branches. Oh, actually, maybe I can start with the vault router branch. So as I mentioned before, we have these entities called ZLP vaults, or Zaros' boosted staking, restaking vaults, where users will put a collateral type as assets and receive shares. So it uses the ERC4626 pattern that everyone knows, but the main difference, sorry, from traditional ERC4626 vaults is that we've permissioned the functions. For example, here, deposit, mint, withdraw, so that only the market making engine proxy can interact with it, right? And you can see like as ZLP is in a set directory outside of the market making directory, it means it's a separate contract. So the actual ZLP vaults, each one is deployed as a standalone upgradable proxy using UUPS and the ERC4626 pattern, so that it is callable by the market making engine proxy through code that is presented at the vault router branch. So here, for example, is where we actually implement like deposit, withdrawals, the actual like permissionless endpoints to the system. So like deposit, you can enter also using like we also have like our own referral modules to work with referral codes, custom referral codes. And then we have like a sort of like a two flow where first you deposit assets to earn shares of a given ZLP vault, depending on the asset that you're using in the vault ID. And then most users, like although like you can leave with your share tokens in your vault, most users will want to stake because that's what you need to do in order to actually earn rewards from the system. So if you're only depositing, you're contributing to the system's TVL and overall credit of the market protocol that is powered by the market making engine. But you need to stake those shares. So like pretty much sending them back to the market making engine proxy in order to earn ETH rewards. Then we also have, of course, unstake. And then our withdrawal, like redemption process works in a two flow where each vault may have a redemption window configured for like a minimal withdrawal delay. So withdrawal happens, as I mentioned, two steps, like you initiate the withdrawal, and then you actually call the ERC4626 redeem function here. So we have like those checks about like checking that withdrawal delay has passed, and hopefully not many vulnerabilities here, but it's that's why we want you guys to review. Okay, so those are like I'd say where most of the permissionless like user or LPs entry points live. Also, like here in the credit delegation branch and the fee distribution branch, we have mainly logic presented for like system keepers, actors, or sort of like protocol level state transitions, where so the core purpose of the market making engine is to connect LPs, providing allocating assets to ZLP vaults that will have this like USD denominated TVL, that's where we use like Chainlink Oracle integrations, for example. And this TVL is used to back the underlying credit or debt of perp markets that were like previously audited in part 1, but now integrate the market making engine in order to consume this TVL from LPs, right? So they can like mint our USD token, which is called USDZ, to pay out traders' profit and ensure that it's always backed and over collateralized by these vault assets. And here at the credit delegation branch is where we have like some of this key functionality that is consumed by the perps engine. So like to get a credit capacity for a market ID, to like get also very important to mention, we've written our auto deleveraging function from scratch, where it's not like traditional auto deleverage engine in a centralized exchange, as it's sort of like more general purpose than specific to perps, as we don't work with an order book model. We work with a peer-to-pool model, similarly to like GMX, Vertex's AMMs, or like those like synthetics as well. So like those on-chain peer-to-pool derivatives exchanges, we don't have an order book. And then in order to like before a trade is settled at the perps engine, where we had that fuel order function. Let me open this here. In the perps engine settlement branch, we have here fuel order. Yeah, fuel market order, or like just the internal fuel order function that handles the another's triggered state transitions in the system. Is where we call it this get adjusted profit from market ID function in order to understand if a given order. Is it good to visualize, by the way, or all good? Okay.
Yeah, okay.
If like all right, thanks, Jess. This is where like we understand if the market ID and the given PNL, unrealized PNL of a trader in this market needs to be auto deleveraged or not. And that's how in the UI level, we will warn users about the system's health. So like, hey, if it's green, it's all right. Like the system is healthy, like funding rates are operating as expected, and there is no like net deleverage to happen to any market. And then yellow, like maybe some markets are entering a dangerous state where by taking this logic here that lives in the, where is it? Your market configuration leaf. And leaves are like, I forgot to mention this for those who are new to Zaros code base. We have like this structure, as I mentioned, like branches are sort of top level modules where external functions live, and leaves are solidity libraries where we handle like mostly utility functions specific to like a smaller entity or object or in Zaros's context. But like also like mainly most libraries are namespaces as well. So we use the ERC7201 storage allocations in order to pretty much allow any branch that is part of the same tree using, so like are linked to the same root proxy, can access the storage of any namespace. So like the market leaf here can be like accessed using the load function being called by essentially like any like of the market making engine branches, like credit delegation branch, the fee distribution branch, stability branch. Any of these branches can access the like stored entities of like markets, like Dex Swap strategies, credit delegations, vaults, all of these by using the load function. And then we have like some additional helpers like load existing, load live to ensure that we are like loading markets or entities in a specific state. Okay, so like getting back to the auto deleverage curve, we use a parallel function that pretty much returns a factor, which is the white coordinate of this curve between 0 and 1, where if the market shouldn't be out of leverage, so if the system state is healthy, if there's like a healthy enough ratio between like delegated credits and the market's total debt, we will always return 1. So like we just don't deleverage the trader's expected profit, unrealized profit. And then like if we were to deleverage a position of a trader, like let's say the trader has a like large position in, I don't know, like a long tail asset, like let's say like Trump USD, for example, this new Trump coin, and then like there's like 100K unrealized profit, but like like the market is in a bad state because people are printing a ton of money, funding rates maybe haven't been configured properly, then we may see a deleverage happen, like taking a cut of the trader's unrealized profit, in order to ensure that always like the end goal, like the first trench or like line of protection are always USDZ holders. Although USDZ is not to be used as a stable coin, like, oh, we want like spin up like curve pools and like run like crazy farming systems. No, it's just you can like for ease of understanding, just visualize it as a chip of the system that is used to reward traders that are making profits and like profitable trades using the Perps engine. Then like those traders that have already been paid out USDZ, we need to ensure that this like system USD is always over-collateralized and backed by the vault's TVL. So this is one of the mechanisms that we use to ensure that this invariant holds true. And the other one, where is I would suggest you guys like having a deeper look to find like maybe some more vulnerabilities, as like it's where it's the hardest part of the system to test, as they integrate with many different components and present some like heavier logic, would be around like the credit delegation branch, the market and vault structs, which is where we trigger what we call the system debt distribution system updates. So like pushing debt from like between end markets to end vaults. So like any vault that may be created with a collateral asset can be linked to many market IDs, and then many market IDs can be linked to the same vault. So we need to ensure that this relationship is always healthy, and we use the recalculate vault's credit capacity function here. Definitely have a look everywhere where this function is called, which is where we trigger this debt distribution updates that ensures that all of the like latest debt coming from markets is pushed to vaults, and that these vaults also like properly allocate this like new like discount this new debt from their share price, and also allocate like ETH rewards and all the different types of rewards properly to stakers. Where else? A little bit on the fee distribution branch, which is where we handle fee distributions, as the name says, to like collect. So that's how LPs, like that's why LPs provide liquidity to a ZLP vault. They put their asset, they expect this asset to be pegged. Like it's not a given, but if the system is economically sound and working, like funding rates, everything working properly over a long period of time, debt and credit shouldn't fluctuate a lot, especially in like bigger markets like BTC, ETH, Link, for example. So if there isn't a large accumulation of net like debt or credit, debt meaning like a discount in the share price and credits being an increase, a premium in the share price, the asset to share relation should be almost one, like as long as possible. And then the trader would be earning like a net APY paid in ETH coming from this receive market fee function, which is basically called when traders are like the Perps engine accumulate fees and traders pay out these ETH fees to the market making engine. Also like very interesting here, we use the concept of Dex Swap strategies to handle like selling all of these different assets like the ZLP vaults are contained or that are collected as from the trader's margin to USDC, which is used to back USDZ in the system. So all of the asset settlements, like credit debt settlements, using the ZLP vault assets or assets collected from the trader's margin, are at some point then converted to USDC, which is used to back USDZ. And then we have the stability branch here, which is where traders that had a profitable position can swap their USDZ for a vault assets or to USDC that has been accumulated by the system here. So we use this full field swap functions, which is also a two-step function, but this time like automated by Chainlink automation. So we don't like request the user to call these two functions. As you can see, like the user just initiates the swaps, passing the vault IDs, amounts in and amounts out. And then the swaps fulfilled at this full field swap function by a system keeper, which is in this case we use here inside external Chainlink keepers, the fee conversion keeper here that handles these swaps. I think that's pretty much it for the system flows. So we started with the vault router branch with the permissionless like user LP flows. Now these are a bit about like system keepers and protocol like routine flows. And then we have finally some a lot of security researchers like to start with configuration. So at the market making agent configuration branch is where we present those functions to like pause and pause markets, configure like Dex Swap strategies, all different entities in the system, and like actors like the fee recipients and like all different sort of configurations live here. So that's also like a good starting point for many security researchers.
Brilliant. Sounds good. Is that everything you'd like to cover?
Yes, I think that's pretty much everything. And myself and João, he's our engineer, will be in the Discord channel to answer any questions you guys may have.
Brilliant, brilliant. That sounds good. Thank you so much for that explanation. It was very, very helpful. There are no questions in the live chat as of yet. So if you do have any questions, then head over to the Discord. As we said at the start of today's stream, there is a Discord channel set up, especially for this contest, where Pedro will be there with another developer from the Zaros team to answer any questions. We did run through the setup at the start of this stream, but if you do have any questions about that, you can ask those in there as well. But hopefully this has been helpful. A quick question in the chat. Somebody has asked, has there been any previous audits? There have been audits by the Cyfrin team. I believe you've been through the one private audit round, and this is the second audit for the contest. Is that correct?
Well, for the entire code base, we had like private audits in a previous contest. For this part specifically, we didn't have any audit yet, but we had some sort of like support from Cyfrin team to not like a formal private audit, but they did help us like to like fix some like the core components of the system and like just like mostly like QA reviews and fixes, but not like a proper audit.
Brilliant, brilliant. Sounds good. So hopefully the auditors will be able to get their teeth into this over the next 2.5 weeks and help find some of those vulnerabilities and make the project more secure. As always, if there are any questions, though, head over to the Discord. But thank you so much for joining us today, Pedro. It's been amazing, and you've definitely given the auditors some head start here into this audit. So thank you very much for joining us.
Thank you very much, Jess. Thank you very much, everyone.
Brilliant. Thank you for watching.